It often says that data analysts, data engineers are the storytellers. Today, we'll tell a story using Python. Welcome to the class of data visualization. My name is Rahul. Let's start. Hello and welcome back to my new video. In my last video, I have talked about NumPy, pandas, and advanced pandas. Okay, so those are the very important two libraries that Python is going to use or you are going to use in your data science project extensively. So data visualization is an important tool in machine learning, as you can already understand. So because it allows you to understand and communicate the insights you have gained from the data, right? Because it helps you like identify patterns, trends, and relationships in your data that might not be immediately obvious just by looking at the CSV file or just by looking at the notepad. You might not be able to tell what is the actual relationship between two features, between two columns, right? So for that you need data visualization. This can especially help you in machine learning, where you are often dealing with large and complex data sets and maybe trying to extract meaningful insights from them, right? So just by visualizing your data, you can better understand the underlying structure of your data set. And definitely this can help you choose the right machine learning model, which is the most important thing, and the right technique for your problem as well. Okay, and it can definitely help you validate the results you are getting from your models. That is why you are doing this work, right? This is the most important thing. You have to predict the real-time data. So maybe in addition, this is also a very powerful way to communicate your findings to your colleague, to your client, to your stakeholders, most importantly to the business, because they might not be able to understand what actually going on inside, with what actually going on inside the machine learning algorithm. Okay, so they have to like understand the data, understand the prediction in a better way, not in a mathematical way, but in a better way, in a non-technical way, in a layman's term, right? So for that, just by creating a clear and concise visualizations, you can effectively convey the insights you have gained from the data, maybe to a very wide audience as well, and which can definitely help drive the decision making and drive action as well. For a company like Google or company like Amazon are only makes their profitable decisions by looking at the data, by looking at the better visualization of the data, right? So overall, data visualization is an essential tool for anyone working with machine learning, as it can help you gain a deeper understanding of your data and communicate your findings more effectively. So Matplotlib and Seaborn are Python libraries basically that are used for data visualization, as I already told you. So they have many inbuilt modules for plotting different graphs. While Matplotlib is used to embed graphs into applications, okay, Seaborn is primarily used for statistical graphs, primarily. Okay, but when should you use this either of the two? So let's understand this with the help of a comparative analysis. Okay, so the table below provides comparison between Python's two well-known visualization package, Matplotlib and Seaborn. We also have a we also have a module called Plotly, but that is just to make your plot looks much better. Nothing else. The fundamental lies with Matplotlib and Seaborn. You have to understand the gist of how you can use your data in a way in Matplotlib or Seaborn that is going to generate a pictorial behavior of your data, right? So first of all, I'll tell you when to use Matplotlib and when to use Seaborn. So Matplotlib is basically to use for basic graph plotting like line charts, bar graphs, etc. And for in Seaborn, it is mainly used for statistics visualization and can perform complex visualization with fewer commands. Okay. Matplotlib mainly works with dataset and arrays, and I mean the specific datasets and arrays. Seaborn works with entire datasets. Okay. Seaborn is considerably more organized and functional than Matplotlib, and treats the entire dataset as a solitary unit. Matplotlib acts productively with data arrays and frames. Okay, it regards the ace and figures as objects. So there are like lots of differences of Matplotlib and Seaborn. As we go ahead, I'll tell you when to use Matplotlib and when to use Seaborn. But let's get started with Matplotlib first and plot a simple graph using a Matplotlib. Okay, so let's start. Let's say you are going to plot a sine curve in Matplotlib using Python, right? So for that, what you have to import? You have to import matplotlib dot pyplot. This is the one as plt, and as plt is like we declare numpy as np or pandas as pd. This is the standard convention of importing matplotlib object into a plt variable. So again, like if you are already know that if you are not having this matplotlib in your system, then please use pip install matplotlib, pip install matplotlib. Okay, so yeah, and you should see that it is starting to install. And for me, since it already installed, but for you guys, please install it if you have not already, right? For me it says requirement already satisfied, so should be okay. I'm deleting it. Okay, so this is the matplotlib import, and also I'll import our favorite numpy as np, right? Perfect. So I have imported both of them, and now I have to just say what is my x and what is my y, right? So my x will be, let's say I'll do np dot linspace, and I'll pass 0 to 2 into, let's say pi, from 0 to pi, okay, and 100, and I'll say y should be np dot sine of x. Okay, so this is our x and this is our y. Okay, now so you can just set to into np dot pi, and it would be 100, right? So 100 samples will be generated, and y is the sine of x. So this is what I have. Now you can just say plt dot plot. So we have this plt dot plot, and here you have to pass your x and y coordinate, as simple as that. So you can just say x comma y. See, so now we have a simple sine curve. Wow. Now, so two things that you have to keep in mind, that this is coming, this is the object basically of this plot that is returning. So to remove it, to omit it, you can do two things. You can do plt dot show. It should remove this line. Okay. Also, you can use this colon instead of plt dot show. Just use this colon. Also, it will work, and it will just update this visualization, and it is embedded in your Jupyter notebook. So that's a very important uh, first plot that you have done, and congratulations. Please make sure and try to follow with me how I'm doing it. So now you can see that it's not a very comprehensive graph, right? You have to definitely let the user know, right? What is in the x level, what is in the y axis, or what is the title of the graph, so that would make this graph more comprehensive, right? So easy to understand, or make it more beautiful as well. So for that you have to use several other commands or methods, you can say, to access your title, to access your labels and all, right? So that is why I have a very handy image that I have. I'll show you what it is, and then you will be able to understand how you can use every corner of this graph to make it more beautiful. So for that, now I am here in the anatomy of a figure. Okay, so what is figure? Figure is basically nothing but a tablecloth, you can say. So in Jupyter, you are going to see this. You have already seen the sine curve, right? So that is So plt.figure was implicit on that, but if you are going to change the figure size or something, you can use this plt.figure. So that is the basic tablecloth where you can say that it's a canvas, and then on top of that you can use your own any graph that that you want to plot. Okay, so this is plt.figure, you can see here. And now let's say this is our graph, right? So this is our plot, and let's say you are going to use uh, a label on the x-axis. You are going to name your x-axis. For that you can use x label. And how you can use it? Using set x label. Okay, so this ax is basically an object of this figure, so you can use that object dot method name to set your title. So let's say set title will be used for the same, for setting a title or naming a plot. Set x label will set the name of x-axis. Set y label similarly will set the name of y-axis. Now you have ticks, right? Ticks meaning like let's say in this picture we have this ticks, right? -1, -7, 0.75, 0.5, 0.25. These are ticks. So in lot of plots that you are going to use in the future, you have to rename these plots, these ticks. Okay, maybe instead of numbers you are going to put a categorical value or something like that. So for that you can use this ticks, which is uh, this ticks, major tick level. Okay, minor tick level. So these you can use to basically format your tick value. Okay, now if you have two graphs in the same plot, so you have to use different colors, right? So for that, and how do you let the customer know that which color represents which graph? For that you can use legend, and the legend is ax.legend. This legend method you can also use to color it, to show the color, which color depicts what, using this legend method. Then you have subplots. So like in a figure that you have plotted already, so let's say in this figure you want to plot 4 plots, right? So something like that you have, if you divide this by 2 horizontally and then vertically, so you'll get 4 plots, right? So this is basically become a 2D array or a matrix, you can say, which where the this coordinate, the leftmost uppermost coordinate will be depicted as 0 0. Then this will be 0 1, which is row 0 column 0, row 0 column 1, column 1 row 0, column 1 row 1. So you separated, you split your figure into 4 different coordinates, right? So using this fig.subplots you can do that. So in the subplots you can provide your number of rows, number of columns, and then you can use that specific coordinate, let's say ax00 or ax01, and plot your existing plots. So for that you can use subplots. Don't worry, I'll show you everything in my class as I go ahead. Okay, this is just to let you know this. When you recall, after I am done with the class, or maybe after your maybe after 1 month or something, this will make lot more sense. Okay, so see, that is why I just want to let you know. So this is it, and let's go back to our next plot, and I'll show you how you can use Matplotlib, how you can leverage Matplotlib to plot bar graphs or the scatter plot or bar plot or line plot, pie plot, right? So let's go. So three most important plots that I'm going to tell you today is, one is line plot, second is bar plot, and third is scatter plot. Okay, so these are very important, these three plots that you are going to use in your daily, any let's say any data science projects, right? So let's start. So line plot. Yeah. So let's say you have an x coordinate, you have, let's say 1 2 3 4 5. Okay, and in y you are just going to use let's say 10, 20, 15, 30. Okay, so let's say you have these two x and y variables. So how are you going to see any relations between these data? Not much, right? But it's very difficult to understand from this numerical or the mathematical representation, right? But if you're going to use a plot, okay, and then visualize the data, what x and y are telling, then it might make much little more sense rather than just looking at this x and y, right? So for that, I'll just use plt dot line. So if you see plt dot plot, this is also basically a line plot. Okay, so if you just do this plt dot plot and do a shift tab, you will see that like lot of parameters, and it's very important again to understand what it is doing, right? So let's say I'll just add few more lines, and then I do shift tab, and here you can see that it's a lot of uh, doc string has been provided, and you should go through all of them individually to understand what all this is basically saying, right? But I'll tell you whatever needed, and but to explore it more you can use your shift tab. So let's say this plt dot plot, and then you just do xy. That's it. So using this you can just say that how this okay, so this is very important stuff, that you have to always make sure that your x and y are on the same length. So here I did 5, okay, but in the y I have only 4. So let's say I'll do 45, and now you will see that this is our data. So you can make use of this visualization to understand that it's kind of a trend which is upward trend, right? You can say that, right, using this. So since we have only 5 data, it might be easily visible from the data, but if you have like billions and millions of data, it's very difficult to understand which trend it is by just looking at the data, because you cannot see the data 5 million data in front of your eyes, right? Because it will be truncated, or it will be shown only 2 3 first 2 3 lines, or last 2 3 lines, so it will be difficult to understand. But using this graphical representation, it is very easy to understand that yeah, there is some dip in this area, but it usually a upward trend, right? So that is a one insight that you can get from just plotting this data. Simple plotting, simple line plot provides you this information that it's a upward trend data. Okay, so let's say this first day I have one stock price which is 10. Next day it went to 20, then it falls down back to 15, then it's 30, then it's 45. So just by plotting it you will understand that yeah, it's now it's making a lot more sense, right? This same data you can plot in a bar plot. So for that you can just say plt dot bar. Okay, and here you can pass all again x and y. So here you will see that first day I have this, my stock price went to 10, then 2, then second day it's 20, 30, for third day it was like around 15, then accordingly 30 and 55, right? So here what you can do, you can just say plt dot x label, right? As I told you, you can pass maybe days, so the x-axis name will be days, and let's say plt dot y label, and you can pass y-axis as let's say some stock price, let's say x stock price, let's say abc stock price. Okay, so now you'll see that it's a days and an abc stock price here. Perfect. You can also add a title, so let's say plt dot title, let's say you can just say that abc trend in last 5 days. Okay, stock price trend in last 5 days. So you can see that it says the title is already there, and you can also use this plt.show again, as I told you, to remove this line. Okay, so now it makes a lot more sense, right? How we're going to use your plot. The same plot you can use it in a scatter plot as well. So scatter plot is basically again a data visualization chart type that basically uses to find the x and y relationships. Okay, the relationships between these variables, and it usually uses the dot to represent the data, the relationship using dots. Okay, so for that you can just say plt.scatter again. Okay, and you can pass x and y. You can copy this 4 as well, so this is similar to what we did already. And now you see that, so this is the point that is used to depict the data. So let's say if you are going to use lot more data, and then it will make lot more sense. So now we're going to plot another scatter plot. Okay, and we'll make some data and we'll see how the scatter plot works. Okay, so let's say I'll make some data. Okay, so what I'll do is I'll first do x. So let's say I'll do random dot normal. Okay, so I'll say my data should be from 0 to 2, and so how many data that I'm going to use? Maybe I'm going to use 20. So this is our standard deviation is 2, mean is 0. Okay, so as you can see, mean is 0, scale is standard deviation. Okay, and size, so how many ones you want? 20. Let's say I want 20. Okay, and so similarly I'll use random dot normal, let's say that, and 0 to 2, and this will be len of x. Let's say similar length we want, so number of elements I said len of x. Okay, so this is our data, and now if you're going to see this plt.scatter, now you will see the xy. So this is our scatter plot. So this is making a lot more sense now, right? That how you're going to use your scatter plot. So this is the relationship between the data as you go along with the along in the x-axis. You will see the data, how the data behavior of the data is changing, right? So now you can add lot more thing in this. So you can add your size, the size of this dot. You can use the colors. So let's say I'll use some size and colors. So I'll do np dot, let's say random dot uniform, and I'll say 0 to 2, and or maybe I'll say 15 to, let's say 40. Okay, and the number of will be len of x, and color also I'll use some colors as well. So color would be 50 to 40, same len of x. Okay, so here in the scatter you can pass your size and color. So if you see S and C, so that you can pass. So it's very easy to understand. So like this S, so if you go here, it say that the marker size, okay, in points multiplied by 2. So this is the marker size. So S I'll pass as size. I'll do S equals to size, and then the C equals to color. I'll pass. So now you will see that it is making sense, right? That we have different data points with different colors. And again I'll do to plt.show, and it will do this. And you can also use this x level, y level, and title to make it a lot more better. So let's say this is data points on x-axis, right, and data points on y-axis, any bivariate distribution, and here you can just say title of the plot. So this is how it is. So and maybe I'll just change the random seed to 3 so that it will generate, and I'll run all. So this is how our scatter plot looks like. It's very easy and very intuitive also, and it's very Python libraries are very smart. So whatever you are providing, you have to just maintain some decorum and some stuff that is well goes well with the net data frame or any array or anything, and Python is going to provide you fantastic plots. Now, so we are going into the next topic, which is histogram. So what is histogram? So histogram is also a very important topic in data science, where you have to heavily use it to understand the nature of the feature. Okay, so suppose you have a data, so like you have a data set, so and that data set contains like maybe 20 features and one target column. So you have to predict the target basically, right? So you have to understand the distribution of each column separately, and histogram helps you do that. So it's basically a graph showing the frequency distributions. Okay, so it is also a graph that shows the number of observations within each given interval. So what is that? I'll show you in the Python. So now let's say I'll create a data. I'll get some data. Let's say I'll do some I'll get some random normal data. I'll go from 0 to let's say 1.5, and I'll have some data like size will be 200. Let's say I'll add instead of taking the standard normal, I'll take some normal distribution. So I'll add 4. Okay, so now I'll say I'll do I have to if I have to find out the distribution of this x variable. Okay, this feature. So it definitely will be a normal distribution, right? So for that I'll just put pld.hist, and I'll just zoom in. Okay, good. Now so here if you do shift tab, you'll see that x, you can pass x, you can pass the bins. So that is what we are saying, that it will show basically the observations within each given interval, right? So that is what bins is. So I'll put x, and let's say I'll put bins equals to 8. So it will be distributed in 8 bins. Okay, and I think you already know that what is normal distribution looks like. It should be a bell curve, right? So I'll say bins equals to 8, and I'll also add some line width. Okay, so line width I'll say 0. Let's say 5. Okay, and I'll say edge color should be white. So you can add these kind of cosmetic changes also. And so let's run this first. So this is basically it's almost a normal distribution, right? So you can see that this is a bell curve. So that means in data science, it's very important to understand the frequency distribution of that particular variable. So if it's a right skewed data, like if it's like that, or maybe it's like that, so that data is very difficult to use in your data set to predict the target, because that will have a like biased data set, that is a biased data set, right? So that definitely you need to pre-process that feature to make it more prone towards the target. Okay, so that is why you have to understand the distribution of the particular feature. So now what I'll do is I'll add some x ticks, y ticks. Okay, so now it's a random 0, 2.5, 5, and 7.5, right? So but I want to add like 0, 1, 2, 3, 4. For each bin I want to add some ticks, basically to understand which bin lies where. And also in this y-axis, I want to add I want to introduce y ticks as well. And I also want to set the x limit and y limit. So let's see how we can do that. We can just say xlim, plt.xlim, and I'll do 0 to 8, and I'll say plt.xticks, that I will do np.arange, and I'll say 1 to 8. Okay, similarly for y limit, I'll say 0 to 56, and plt.yticks I can do, maybe let's say np.linspace, uh, linspace 0 to 56, and space will be 9. So it will be basically 9 into 7, 56. So 0, 7, 14, something like that it will come. Okay, and I'll add plt.show as well. So now if you run it, you will see that it's very easy to understand now, right? How it is 0 to 56, and then 1 to 7, everything. So this is how you can introduce your limit, you can introduce your ticks. Okay, and you can show your data distribution using this hist plot. Very important, please keep this in mind. And the next plot will be pie plot. Okay, so today this will be our last plot, and in the next video I'll show you the complete end-to-end how you can use your exploratory data analysis, which is the data visualization, from a data set. Okay, so we'll have a data set, we'll take some data set, and I'll show you how you can use your EDA skills, data visualization skills, to get the gist of the data, how the data looks like. Okay, so for that, so I told you like these four plot types, and the last plot type I'll show you is pie plot, so which is also very important. You might need, you will need it in your future data science projects. So for that, I'll have just a data, let's say I'll have 1 2 3 4. Okay, so some data I'll have, and I'll show you how uh, the pie plot looks like. Okay, so we can do plt.py, but I'll show you how you can use subplots. Okay, so let's say you can use plt dot subplots as well. So what is this subplots? This is very important. The detail I'll go with this subplots in my next video, but today I'll just show you how subplots work. Okay, so this subplots, if you do shift tab again, you will understand that this subplots is basically the total will be a single figure, but now you can divide, as I told you before with that picture, that you can now divide the single plot, the single tablecloth, okay, into 4 different quadrants, 8 different quadrants, whatever you feel like, along by giving this n rows and n columns. Okay, so by default it's 1 1. So even if you do subplots, it will only create one figure, like the one quadrant of a figure of the whole figure. But if you provide like 2 2, it will create 4. And how it will do, so like if you see that it returns, so if I go down, let me add few more cells, and if you do shift tab, you will find out that it returns two things basically. This is the figure, it returns the whole figure, and the axis. Okay, so axis is basically, so like if you use n rows and n columns as 2 2, so then axis will be like 4 ax1 ax2. So if you provide 1 2, it will do like this, ax1 ax2. If you provide 2 2, it will return like this, ax1 ax2 ax3 ax4. So with each ax4 ax1 ax2, you can plot the graph into that quadrant. Okay, so that is the main aim of this plt.subplots. Very important, you will need this subplots only in your next any project, Okay, so please keep this in mind. So this is basically what this plt subplots will return: figure and axis. Okay, so and not, if you just provide one, then you might not need figure, or maybe if you provide two also, you might not need figure. If you don't need this, you can just pass underscore onto that on the return value, but something like this. So first is figure, right? So figure you don't want, you want ax, so you can just say like something like this. Okay, so this basically ax will contain the object of that figure, or the total figures object it will contain ax. So now you can just say ax dot pi, okay, and pass x. So something like this. So if you run this, you will see that. So this is the four portion, and this is the three portion, 2 and 1, 1 2 3 4. This has been plotted something like this. Now you can beautify it. So first of all, you can, to remove this, you can just add this colon, right? Now if you want to label the each quadrant, okay, so let's say you want to label all four. So for that you can just have these labels. You have these labels. So in labels you can pass maybe, let's say AA, BB, CC, and DD. Okay, so something like that you can pass. If you run it, you will see that it has been. So corresponding AA corresponds to 1 1 1. So the smallest group has been assigned as AA. So something like that you can add. Okay, and also you can have something like there are like lots of others as well. So you can pass these colors, you can pass by default, this is the color. You can also pass colors. You can pass this properties, you can pass. So let's say I'll pass line width. So this takes a dictionary. So if you shift tab, you'll see that this takes a dictionary, this one. So this takes a dictionary. Okay, so you can pass line width, and then each color you can pass something like that. So you can say this line width will be the key, and value, let's say 1. Also I can pass each color, okay, is white. It will be colon white. Okay, so this you can pass. And also you can pass frame equals to true. So this frame, so let's say first do that. So this is the age color, so you see that age has been now white. And let's you can also add this frame to true. So it will add the axis. So like behind this pie chart, it will add the axis. So something like this. So now you can see that it has been little spill over, right? The CC, BB, DD and BB still fine. CC and A spills over. So for that you can just you want to the increase of total figure size, right? So this the fig size you can pass here. So you can say that fig equals to let's say you can pass maybe 6 by let's say 4 by 4. Okay, it should be fixed size, I think. Yeah, so let's say I'll pass 5 5 maybe in that case. Yeah, now it's good. 6 6 accordingly you can adjust, as you can understand, right? And now you can also set the center. Okay, set the radius. So let's say I'll set the center maybe 4 by 4. So at 4 4 this the circle center will start. So if you run this, so you see that this is the center, right? And you can also pass the radius. Radius, let's say 3, let's say 5 4. Okay, What is the issue? Oh, okay, this is a spelling mistake. Yeah, radius. So this radius also you can pass. So several parameters you can pass to make this more beautiful. Center, right? And yeah, that's it. So this is our pie chart. Very interesting. Please keep this in mind. And as I told you in my next video, that will be a very important and a very exciting video, because I'm going to grab some data sets from the internet, and then I'll show you how you can approach a data science or a machine learning project. Okay, so only for the data visualization part, and then we'll go to the final thing of machine learning. Okay, so for that, please stay tuned, and please revise whatever I have told you. I have showed you the entire playlist of this machine learning and data science. Please revise, and we'll see you in my next video. Guys, thank you, and goodbye, and happy learning. If you like my content, please like, share, and subscribe.